Discuss about the animal kingdom. In the previous class, we had discussed the symmetry, coelom and coelomates. Then we had also discussed about diploblastic organisms. All those we had discussed in the previous class. Today's class, we are going to discuss about three phylums which are under invertebrates. So what we are going to study about is phylum Porifera, which is commonly called as sponges. Then phylum Coelotrata, which is also called as Cnidaria. C is silent there. Then phylum Platyhelminthes, which is also called as the flatworms. See, phylum Porifera, a primitive type of animals. Porifera, as the name indicates, the body has a lot of pores on them. So we call them as Porifera. You might have already drawn a diagram of sponges in your records, isn't it? So they are, some of them are sedentary. They are fixed to a place. Most of them are sedentary. They are fixed to a place, and you find numerous pores on them. So we call these pores as ostia. The opening, a single opening is there, which we call it as osculum. See, on the body wall, they have a large number of pores, which we call it as ostia. The water enters through this ostia, and they also carry the food substrate and the exchange of respiratory gases. Everything happens through this water canal system they have. Okay, there's a central cavity within them, which we call it as spongocoel. So from the pores, they enter into this central cavity called as spongocoel, and this water is thrown out this common opening called as osculum. So through that water that is thrown out, waste materials are also thrown out. The unnecessary respiratory gases are also eliminated out. So remember about this water canal system that is there. Now, poriferans, they don't exhibit tissue level or organ level or organ system level. They are primitive animals, as I told you already. So they exhibit the, what you call it, as cellular level of organization. Not even tissues, they are at cellular level of organization. And there is a division of labor in these cells. There is a division of labor in these cells, especially choanocytes or collar cells are found lining this spongocoel. This cavity, what is found when you dissect it inside the spongocoel cavity is found. They are lined by choanocytes or collar cells, we call them as. If you look into the organisms, majority of these poriferans are marine and they are asymmetrical. You cannot divide them into two equal halves in any plane. Such symmetry we call it as asymmetrical. You cannot obtain two equal halves at all. So asymmetrical animals, cellular level of organization, they have water transport system or water canal system where water enters from outside through these pores and they enter into the body cavity called as spongocoel, and they are thrown out through this osculum. Osculum is the only opening that they have. Okay. Then water enters through minute openings called ostia in the body wall and it leads to a central cavity called as spongocoel and is thrown out through osculum. Okay, the upper part of it. Water transport system that is present here helps in food transport, respiratory substance, substrate exchanges and removal of waste. Choanocytes or collar cells are found lining the spongocoel, which I have already discussed about. Intracellular digestion, within the cell digestion takes place. For us it is extracellular digestion outside the cell, within a cavity called as stomach, intestine, it is happening. Okay, but within the cell they have undergoing digestion. The skeleton is made up of silica, spicules something. Spicules or sponges, they are made up of silica or some of them are also made up of calcium carbonate. There is also a classification of poriferans, Demospongia, okay, Hexaactinellida. Hexaactinellida has 6 needle-like structures in the spicules. Okay, Demospongia. So there are different Calcarea. Demospongia is spicules which are made up of silica. Calcarea ಅಂದರೆ calcium carbonate ಇಂದ ಮಾಡಿರುವಂತ spicules. That classification they have not given, but even you have classification of poriferans on the basis of chemical nature of the spicules, type of spicules. Okay. So asexually they reproduce by fragmentation and sexually by producing gametes. Fertilization is internal and development is indirect. And they are hermaphrodites. That is, they are bisexual. There is no male and female separately. Both male and female gametes are produced by the same individual. Okay, hermaphrodites or bisexuals ಅಂತ ಕರಿತೀವಿ. This is about the phylum Porifera, Cycon. You have to remember about it. There is a freshwater sponge, which we call it as Spongina. Most of them are marine form, but there is also a freshwater form, Spongina. And there is bark sponge, which we call it as Euspongia. You might have noticed those bark sponges which you use. They are termed as Euspongia. These are all about the sponges or poriferans. Then phylum Coelenterata. They have a coelenterate or a gastrovascular cavity, and they are also called as cnidarians because they have stinging cells or nematocysts. Okay, they have nematocysts or nematocytes. They call it as stinging cells. Okay, so now what are the examples under phylum Coelenterata? From corals, you come across hydra as an example. Then jellyfish, which we also call it as Aurelia. Physalis, Portuguese man of war. Then sea fan. Then there is also the brain coral, Meandrina, Gorgonia, sea fan. Sea pen, Penatula. Adamsia, sea anemone. Okay. Then there is Obelia. So these are all the examples for Coelenterata or cnidaria, where they have the special cells, stinging cells or nematocysts, which not only helps in paralyzing the prey and capturing them, but it also helps in overcoming the predators. Okay, there is a symbiotic, not symbiotic, there is a commensalism and the association between sea anemone and clownfish. You might have watched the movie Finding Nemo. They usually go in hiding within the sea anemone. Okay, the sea anemone doesn't get benefited, but the clownfish gets protection from the sea anemone because of the stinging cells that they have, and they are going to scare away the predators. Okay, remember about that. Now if you look into the characteristics of phylum Coelenterata, for the first time you see them having tissue level of organization, whereas in Porifera it was cellular grade of organization. Tissue grade of organization, you can notice. They are marine forms, sessile means they are fixed to a place, or free floating also you can find. Free swimming is also there. Tissue level of organization and diploblastic. They have two layers, outer ectoderm and inner endoderm. Middle layer is having a fluid which we call it as mesoglea. Okay, so radially symmetrical animals, whereas poriferans they were asymmetrical. Here you find them to be radially symmetrical animals. They have stinging cells called as cnidoblasts, cnidocytes, which are found on the tentacles, and they help in not only capturing the prey but also scaring away the predators. Okay, it is also protective in function, not only help in capturing the prey but also protective in function. The stinging cells or the cnidoblasts or cnidocytes. The central gastrovascular cavity is present with a single opening. They don't have mouth and anus. They have a single opening, hypostome anta karite. Both mouth and anus is present as a single opening. Okay, so hypostome anta karite. Digestion is extracellular as well as intracellular. Now corals have skeleton which is made up of calcium carbonate. Corals you might have seen it, I will be showing you that example also. Cnidarians, their body type, you can notice two types in their body type, alternation of generations with a ಕೆಲವರಲ್ಲಿ. One body type we call it as polyp, where they look like hydra. Hydra, you know that they are long and they have tentacles, hydra, they hypostome iರುತ್ತೆ. Whereas jellyfish, they would be umbrella shaped. Isn't it? Jellyfish should be umbrella shaped, that we call it as medusae. So they have two generations, medusa or medusae. Polyp and which is hydra-like structures, medusa which is jellyfish-like structures. They show this alternation of generations. Obelia nallide adu. Obelia exhibits alternation of polyp and medusa generation. So the polyp is going to undergo asexual reproduction to produce medusae or medusa, and medusa undergoes sexual reproduction to produce polyp. That sort of alternation of generation is there. This alternation of generation which is found in Coelenterata, we call it as metagenesis. Metagenesis or alternation of generations that you find in Coelenterata. Now there is one more phylum, very small phylum, phylum Ctenophora. Phylum Ctenophora. before Phylum Platyhelminthes. They are also commonly called as sea walnuts or the comb jellies. Sea walnuts or comb jellies. The examples are Pleurobrachia and Ctenophilina are the examples. Even they exhibit this diploblastic condition, bilaterally symmetrical. Then they have comb plates. Nearly 6 to 8 pairs of comb plates are there, which helps them in locomotion. Comb plates help them in locomotion. Okay, and they exhibit bioluminescence. That is, in darkness they glow. So these are noticed in case of this Ctenophora, Phylum Ctenophora, which are commonly called as sea walnuts or comb jellies. They have comb plates and bioluminescence. You have to remember about it. Okay, and the examples are Pleurobrachia and Ctenophora. The example Ctenoplana are example for Phylum Ctenophora. That is a small phylum that you should also remember about. Then the next important phylum is Phylum Platyhelminthes, or we also call it as flatworms. Example for this, the Tinea solium, tapeworm. Then there is example of liver flues, Fasciola hepaticum, liver flu. Okay, planaria. These are all examples of this Platyhelminthes or flatworms. For the first time they show organ level of organization, not organ system, organ level of organization. They are triploblastic. Then acoelomate, that is, coelom is absent. Triploblastic, acoelomate, and you also notice bilaterally symmetrical. Still there you notice them as radially symmetrical. For the first time in Platyhelminthes or flatworms you find this bilaterally symmetrical, triploblastic, acoelomate. Okay, so remember about that. They dorsoventrally flattened body, apache ಆಗಿರುತ್ತೆ, ಅದಕ್ಕೆ flatworms ಅಂತ ಕರೀತೀವಿ. Most of them are parasites and endoparasites mostly, and some of them are ectoparasites also. Some of these parasites are found in human beings. Many times I tell that we are the host. We are home sweet home for many worms. We don't know how many worms are there in our small intestine and other places. So many times we ourselves become home sweet home for these parasites. So it might be tapeworm or it might be liver fluke, which is found in the liver. Okay, so remember about that. Most of them are endoparasites and they are also found in human beings, occurring in human beings. Bilaterally symmetrical, triploblastic, acoelomate with organ level of organization. Then they have hooks and suckers because they are present in the intestine, and they should hold on to the walls of the hooks intestine, or else they would be thrown out with the undigested food material. So hooks and suckers helps them to get attached to the walls of the intestine. They help them better adhesion to the host. Okay, and they also have flame cells, which not only helps in regulation, osmoregulation, but also it helps in excretion. They are bisexuals. Flatworms are bisexuals or hermaphrodites. They have both male and female reproductive organs on the same worm. They can't go for dating there because it's a limited space, small intestine and there. So there you can find only one organism, not 2 or 3. So most of the time this hermaphrodite helps them in increasing their numbers. So they need not have to go in search of the mates there. So they have both the male and female reproductive organs in the same individual, so we call them as bisexuals or hermaphrodites. They have a thick layer, cuticle at the end, which prevents from the digestive enzymes, or else these worms also gets digested. Once they are in the small intestine, large amount of digestive juices are also there. So this cuticle prevents them from being digested. Their life cycle is very complex. They have more than one host. Take the example of human liver fluke. It requires a snail and a fish as a host. First primary host is snail, secondary host is fish. Only then this improperly cooked fish, if a man consumes this human liver fluke, it infects them. They cannot directly infect human beings. So they require many intermediate hosts. So their life cycle is very complex. Fertilization is internal and several stages are involved in development. Okay, so planaria, they have high power of regeneration. Even if they fragment, they form a new organism. So the power of regeneration is very high in case of this planaria. So these are points that you have to remember regarding this phylum Platyhelminthes. So there are some things that you have to look into. So what is this coral? How does it look like? So the meandrina, brain coral idangira. Okay. So meandrina is there. This is the coral, calcium carbonate. The skeleton is made up of calcium carbonate. Okay. So coral islands, they are formed from corals from the past. Then there is a flatworm, tapeworm is there of Taenia solium. So where you can notice the length of it. You might have even drawn the diagrams. It's an hermaphrodite, example for the flatworms. Okay. Then we have this cycon sponge, where you can see at the top region the osculum and numerous pores on them. Since they are dry, you cannot see the pores so well. But they have numerous pores on them called as ostia. A central cavity called as spongocele. You can notice it at the bottom. Spongocele. Okay. So these are things that you have studied even in your practicals of this phylum. So that is what you have to remember about.